The Atlantic Ocean, one of the 5 major oceans of the world and plays a central role in global geography, climate, and human history. It is the second largest ocean on Earth, covering an extensive area and connecting numerous continents. Its vastness, strategic location, and unique natural features make it an indispensable component of the planet's hydrosphere. Geographically, the Atlantic Ocean lies between the continents of North and South America to the west and Europe and Africa to the east. Its northern boundary is marked by the Arctic Ocean, while its southern limit merges with the Southern Ocean near Antarctica. The Atlantic stretches from the icy waters of the Arctic in the north to the frigid Southern Ocean near the Antarctic, thus spanning diverse climatic zones. The ocean is traditionally divided into 2 main regions, the North Atlantic and the South Atlantic, separated roughly by the equator. The North Atlantic extends from the Arctic Ocean down to the equatorial region near the Caribbean, encompassing important seas such as the Caribbean Sea, the Gulf of Mexico, and parts of the Mediterranean Sea. The South Atlantic, on the other hand, spans from the equator down to the icy waters surrounding Antarctica, touching the coasts of South America and Africa. Several significant straits and seas are part of the Atlantic's geography. The Strait of Gibraltar, connecting the Atlantic with the Mediterranean Sea, serves as a strategic maritime gateway. The Sargasso Sea, located in the North Atlantic, is a unique region distinguished by its floating seaweed and calm waters. The Atlantic also connects to the Arctic Ocean through passages such as the Davis Strait and the Greenland Sea, and it links to the Southern Ocean via the Drake Passage near the southern tip of South America. The Atlantic Ocean covers an approximate area of 106 million square kilometers, 41 million square miles, making it the second largest ocean after the Pacific Ocean. Its length from north to south is around 15,000 kilometers, 9,320 miles, while its width varies significantly. The Atlantic is generally narrower than the Pacific, averaging 2,500 to 4,000 kilometers, 1,550 to 2,485 miles, in width in the northern and central regions. In terms of depth, the Atlantic has an average depth of about 3,646 meters, 11,962 feet, with its deepest point being the Puerto Rico Trench, which plunges to approximately 8,376 meters, 27,480 feet. The ocean basin is characterized by a wide range of underwater features, including continental shelves, slopes, abyssal plains, and mid-ocean ridges. Notably, the Mid-Atlantic Ridge is a massive underwater mountain chain that runs almost the entire length of the ocean, dividing it into eastern and western halves and serving as a site of continuous seaflow or spreading. The continental shelves along the Atlantic coasts are relatively broad in regions such as the east coast of the United States, the Gulf of Mexico, and parts of West Africa. These shelves are rich in marine resources and support dense populations in coastal regions. Deeper areas, like the abyssal plains of the Central Atlantic, are less explored but play a vital role in oceanic circulation and deep-sea ecosystems. The Atlantic Ocean exhibits a wide variety of physical, chemical, and biological characteristics. Its salinity averages around 35 parts per thousand, though it varies slightly due to evaporation, precipitation, river inflows, and ocean currents. The North Atlantic tends to be saltier due to higher evaporation rates and lower freshwater input, while areas near the equator may have slightly lower salinity because of abundant rainfall and river discharge. Temperature in the Atlantic varies dramatically. The northernmost regions, such as near Greenland and Iceland, are cold, with surface temperatures sometimes falling below freezing in winter. Tropical regions, such as the Caribbean and West African coasts, maintain warm waters exceeding 25 degrees Celsius 77 degrees Fahrenheit. The vertical temperature gradient is also notable. Surface waters are much warmer than the deep ocean, creating a stratified environment that affects marine life and global ocean currents. The Atlantic Ocean is known for its complex system of currents, which play a crucial role in regulating global climate. The Gulf Stream, originating in the Gulf of Mexico, transports warm water northwards along the eastern coast of the United States and across the Atlantic toward Europe. This current moderates climate in Western Europe, making it warmer than other regions at similar latitudes. The South Atlantic has its own circulation system, including the Brazil Current and the Benguela Current, which influence weather patterns, fisheries, and nutrient distribution. The ocean also experiences tides, waves, and storms that vary by region. The Atlantic is infamous for its hurricane season, particularly in the North Atlantic between June and November. These storms arise from tropical waters and can have devastating impacts on coastal communities. Additionally, the Atlantic's surface is home to waves of varying magnitude, from gentle swells in the mid-Atlantic to powerful waves along the coasts of Europe and Africa. The Atlantic Ocean supports an extraordinary range of ecosystems and marine life. Its coastal regions are home to mangroves, estuaries, coral reefs, and tidal flats, providing habitats for countless species of fish, crustaceans, and birds. In the open ocean, pelagic species such as tuna, sharks, and whales thrive, while deep-sea environments host unique organisms adapted to extreme pressure and darkness. The Atlantic also plays a critical role in global nutrient cycling and carbon sequestration. Phytoplankton, microscopic plants at the ocean surface, perform photosynthesis and produce a significant portion of the world's oxygen. Additionally, the Atlantic's currents transport nutrients across vast distances, sustaining both local and distant ecosystems. From a human perspective, the Atlantic Ocean has been a corridor for exploration, trade, and cultural exchange for centuries. During the Age of Exploration, European nations crossed the Atlantic to reach the Americas, initiating trade networks that connected continents and reshaped global history. Today, the Atlantic remains a vital route for international shipping, connecting ports from New York and Rotterdam to Lagos and Buenos Aires. Its natural resources, including fish, oil, natural gas, and minerals, continue to be of immense economic importance. The Atlantic Ocean, with its vast expanse and dynamic systems, is not only a geographical giant but also a crucial regulator of global climate, a hub of marine biodiversity, and a foundation for human economies. Its influence extends from the smallest microscopic plankton to the largest international shipping networks, making it integral to life on Earth. Climate and oceanic influence. The Atlantic Ocean is a major driver of the world's climate, acting as a thermal reservoir, a conveyor of heat, and a regulator of weather patterns. Its surface waters absorb large amounts of solar radiation, which in turn influences the atmosphere and global temperature distribution. One of the most significant climate-regulating systems in the Atlantic is the thermohaline circulation, often referred to as the global conveyor belt. This system moves warm, salty water from the tropics toward the poles and returns cold, dense water toward the equator. In doing so, it redistributes heat and plays a vital role in stabilizing climate across continents. The North Atlantic, in particular, affects European and North American climates through the Gulf Stream and its continuation, the North Atlantic Drift. These currents transport warm tropical water northwards, moderating winters in Western Europe and influencing rainfall patterns. Conversely, disruptions in Atlantic currents can lead to extreme weather events, including prolonged droughts, storms, and temperature fluctuations. The Atlantic Ocean is also the origin of many tropical cyclones and hurricanes, especially in its northern tropical and subtropical regions. Between June and November, warm waters in the Caribbean and the Gulf of Mexico fuel hurricanes, which can reach enormous intensity and cause widespread damage. These storms are not only meteorological phenomena but also integral to the ocean atmosphere system, redistributing heat and fresh water across the Atlantic basin. The Atlantic Ocean is home to a staggering diversity of life, ranging from microscopic organisms to the largest mammals on Earth. Its ecosystems can be broadly categorized into coastal, pelagic, and deep-sea environments, each supporting unique forms of life. Coastal ecosystems. The coasts of the Atlantic are lined with mangroves, estuaries, salt marshes, and coral reefs. These areas serve as nurseries for countless fish species, support migratory birds, and protect shorelines from erosion. For example, the Amazon River estuary in South America delivers nutrients to the Atlantic, fostering highly productive fishing grounds. Similarly, the Caribbean coral reefs sustain a rich variety of marine life, including colorful fish, mollusks, and sea turtles. Pelagic zone: the open waters of the Atlantic host large populations of migratory species such as tuna, mackerel, marlin, and sharks. These waters are also vital for marine mammals like dolphins, whales, and seals. Phytoplankton in the surface layers form the base of the food chain, converting sunlight into energy and supporting the entire marine ecosystem. Deep sea environments: the Atlantic's abyssal plains and trenches, particularly along the mid-Atlantic ridge, are home to specialized deep-sea organisms. These include bioluminescent fish, tube worms, and unique crustaceans that thrive under extreme pressure and darkness. Hydrothermal vents along the ridge support ecosystems independent of sunlight, where bacteria convert chemicals into energy through chemosynthesis. The Atlantic's biodiversity is also shaped by its currents, salinity, and temperature gradients, which facilitate migration and nutrient cycling. For instance, the upwelling zones off the coast of West Africa and the Caribbean bring nutrient-rich waters to the surface, supporting large-scale fisheries and feeding migratory birds. The Atlantic Ocean is a cornerstone of global economies, providing essential resources, transportation routes, and opportunities for energy production. Its economic significance can be understood in several key areas. Fisheries and aquaculture: the Atlantic Ocean supports one of the world's most productive fishing regions. Countries along its coasts, such as the United States, Brazil, Spain, and Morocco, rely heavily on fish and seafood for both local consumption and international trade. Major species include cod, herring, tuna, and shrimp. Sustainable management of these fisheries is crucial, as overfishing and climate change threaten marine populations. Shipping and trade: the Atlantic has historically served as a major trade route, connecting Europe, Africa, and the Americas. Today, it remains vital for international shipping, transporting oil, gas, manufactured goods, and raw materials. Major ports such as Rotterdam, New York, Hamburg, and Lagos are hubs of commerce, facilitating billions of dollars in trade annually. The ocean's strategic straits, like the Strait of Gibraltar and the Bahamas Passage, further enhance its importance in global logistics. Energy resources: the Atlantic holds significant natural resources, including oil, natural gas, and offshore wind energy potential. Offshore drilling in the North Atlantic, the Gulf of Mexico, and the coast of West Africa has become a major source of hydrocarbons, though it raises environmental concerns. More recently, countries are exploring renewable energy options, including wind farms in the North Atlantic, which harness the ocean's powerful and consistent winds. Tourism and recreation: the Atlantic Ocean also contributes to the economy through tourism. Coastal regions, tropical islands, and beaches attract millions of visitors annually. Activities such as cruise tourism, diving, and recreational fishing generate income and employment, particularly in regions like the Caribbean, Florida, and the Azores. Research and scientific exploration: beyond economic resources, the Atlantic serves as a natural laboratory for scientific research. Oceanographers, climate scientists, and marine biologists study currents, marine species, and ecological changes in the Atlantic to understand climate change, biodiversity conservation, and ocean dynamics. Discoveries from these studies not only deepen our understanding of the ocean but also inform policy and sustainable management practices. Despite its importance, the Atlantic Ocean faces numerous environmental threats. Pollution from plastics, oil spills, and chemical runoff endangers marine life and ecosystems. Climate change is causing ocean warming, rising sea levels, and acidification, which affect fisheries and coastal communities. Overfishing, habitat destruction, and invasive species further exacerbate ecological stress. International cooperation: such as agreements under the United Nations Convention on the Law of the Sea, UNCLOS, is critical to protecting the Atlantic's health and ensuring its sustainable use for future generations. The Atlantic Ocean is far more than a vast body of water, it is a lifeline for the planet's climate, ecosystems, and human economies. Its currents regulate global temperatures, its waters sustain a rich tapestry of marine life, and its coasts and resources fuel economic activity for millions of people. Yet, the Atlantic's continued vitality depends on sustainable management, scientific understanding, and global stewardship. By recognizing its significance and addressing the environmental challenges it faces, humanity can ensure that the Atlantic remains a resilient and productive ocean for generations to come. In summary, the Atlantic Ocean is a vast and dynamic body of water, stretching between the Americas and Europe/Africa, with an impressive size of over 100 million square kilometers and depths reaching over 8,000 meters. Its diverse nature encompassing temperature variations, salinity gradients, powerful currents, rich biodiversity, and complex underwater topography makes it a cornerstone of the Earth's environmental and human systems. Understanding its location, size, and natural characteristics is essential not only for geography but also for ecology, climate science, and global history. Thank you for watching this video.